To represent a point in 3 dimensions, we use another axis called the z-axis. To represent a vector in 3 dimensions, we have to introduce another unit vector in the positive z direction. That's called k. So we have 3 unit vectors, I, j and k. So any vector r can be built up from these 3 unit vectors. We can think of vector r as the sum of 3 vectors. This is one of the 3 vectors. This vector is a times I, unit vector I. So this is actually the positive x direction here, but there's no reason why we're choosing the axes as they are. This is the positive y direction, this is the positive z direction. This vector here is b times unit vector j. So this number is b, could be positive or negative. It happens to be positive here, because this is the usual convention for the XYZ coordinate system. If we get the sum of AI and BJ by the parallelogram law, we have this vector here. Now we have this third vector. This is the z coordinate of point P. This vector has magnitude c. It's actually positive. That's why I'm talking about the magnitude. The magnitude or modulus is always positive. We happen to be in the positive z direction here. But c could be negative. In that case, we'd have to make it positive if we're talking about the magnitude. But anyway, this is c times unit vector k. And of course it's this vector here also. This vector here is c times unit vector k. So we could imagine adding this vector here onto this vector here by the parallelogram law to get vector r. I'll just try and highlight that. So we could imagine adding vector ck onto this vector here, which is ai plus bj by the parallelogram law to get r. Or we could add this vector onto ck this way by the triangle law to get vector r. So vector r is ai plus bj plus ck. So we add ck onto this here. So once we know the coordinates of the head of the vector, assuming the tail is at the origin, then we can straight away write down the vector running from the tail, running from the origin to the point. So a, b and c are the coordinates of the point. So let's take this example. Suppose the point is coordinates 9 minus 8, 6. Then the unit vector is 9i minus, the position vector of this point is 9i minus 8j plus 6k. Now let's consider the modulus of vector r. Now we can use Pythagoras' theorem to deduce this. So the modulus of r is the length of r. So to do that, we start by getting the length of this line here. Well, this line is the hypotenuse of a right angled triangle whose sides are of length a and b. Now if b happens to be a negative number, it doesn't matter because we'll be squaring these. So here's our right angled triangle. So this is the hypotenuse, so the length of it is the square root of the sum of the squares of the short sides. And even if a or b are negative, it doesn't matter, we're squaring them. So that's the length of this line here. Now the length of this line here is c. Well, we could indicate the magnitude with these vertical lines, but it doesn't matter. We'll be squaring it because we have another right angled triangle here. So one side is root a squared plus b squared and the other short side is c. So to get the hypotenuse, what do? Well, we get the square root of the sum of the squares. So we have to take root a squared plus b squared and square it, and then we have to take this distance c and square it. Well, that's just going to give us root a squared plus b squared plus c squared. So r without any other notation means the magnitude of vector r. We can also write it like this, of course. So let's look at this example here. Well, it's simple. We just square the components, sum them, and take the square root.